Hello, good morning, good morning. Very good morning, Ira, Petya, Agatha, everyone. Good morning. How are you all? What happened, Ira? How are you?
I'm fine, sir.
Wow, that's great. That's great. Good morning, Agatha. See you after a long time. Edit, good morning. Vidya, good morning. Miracle, good morning. Everyone turn on your camera so that we can start our class. And we were doing electrical energy and we did some important topics. For example, yesterday we did Ohm's law. And with the help of Ohm's law, we got one formula. The formula is V is equals to IR. Okay. Here V stands for potential difference. I stands for current and R stands for resistance. Okay. So this is what we learned in the thing. Yes or no? Yes or no? Okay, Agatha, you saw the video?
Well, I couldn't really watch eh, the first video fully.
Okay, okay. So second also you didn't watch then.
No, second I couldn't.
Okay, I know it's boring. So you can do 1.5x. You can use 1.5 and then you can skip all whatever the Betya talks in the class. Okay. So so this is how you can use. Okay. Sorry for that. So now what I'm saying. Yeah. So we'll do one question. So basically, what does this statement means? For a brief introduction, I will give you the brief introduction. This statement says that in a conductor, in a conductor, if I will increase the potential difference across the conductor, then the current also increases. This is what this statement says. Okay. For example, okay, like I took 2-volt battery, and in 2-volt battery, for example, if I get 2 ampere current, okay, for example, in 2-volt battery, I got 2 ampere current. Okay, this is random data which I'm taking. Now, if I will triple the voltage, means if I will use 6-volt battery, then this like into 3, then this current will also will multiply by 3, means 6 ampere current will automatically it will come. So George Simon Ohm, he used this conductor and he find it out when he triples the voltage, the current also triples. Means the current also increases in the same ratio. Did you understand? Yes or no? Okay. Now if I will do 4 times, like 6 4 24 volt, then the current also multiplied by 4 makes it 24 amperes. So what does this mean? This means that the proportion that you are taking to increase the voltage, in the same proportion the current will increase. It means that V is directly proportional to I. If you will increase the V in the same proportion, I will also increase. Did you understand? Yes or no? And when they remove the proportionality sign, we got a relationship as R. R is a constant value. R stands for resistance, which is a constant value of a conductor. Now, for a brief introduction of resistance, what is resistance? Resistance is the property of a substance ability to resist the flow of current. Okay, resistance is the ability of a property of a substance ability to resist the flow of current. So resistance means resist the flow of current. So from this, what we got that okay. For example, this is a plastic scale, and there is one iron scale is there. So if you will use the plastic scale and if you will put into the electrical socket, Then, because the plastic cell has more resistance, it has that much resistance, it won't allow the flow of current pass through it. This is the property of plastic. It has high resistance value. From this we get one more equation, that the resistance of a conductor is indirectly proportional to the current. If resistance is high, then current is low. Like current flow is low. So, because this is an insulator, what is insulator? That does not allow electricity to pass through it. This is called as insulator. Now, because this is insulator, when I will touch this plastic scale with the electrical board, it has high resistance. High resistance means it won't allow the electricity to pass through it, and I will be safe. And instead of this plastic scale, if I will take iron scale has low resistance. And if I will put the iron scale into the electric socket, because iron has low resistance, it will allow the flow of electric current, and it will allow me to have a lunch with Jesus. So basically, the thing is, low resistance means flow of current, more resistance means no flow of current. Did you
Okay.
understand? This is what we learned.
So resistance is directly proportional to 1 upon current.
One indirectly proportional. Basically, it's not called as directly proportional. It is called as indirectly proportional. If resistance of a conductor is high, the flow of current in that conductor will be low.
I mean, not directly proportional. I just said that R is proportional to 1 upon I. Just
Yeah, 1 upon I. Yes. Did you understand that we learned in the previous class? Okay. So we got one relationship. So now I will give you one question. I mean, I will solve it. Then you guys write it down. This thing.
please.
So if just give me a second, beta. If 220 volt
Sir,
is, yes,
um, did we learn about, did you all I don't know what is I current. What's the difference between the current and the volt?
the volt is the potential difference, which is okay. I will give one information. So, for example, this is for example battery. This big line means plus, and this sign is negative. So I told you, electrical cell generate current. So the electrical cell is basically is measured in volt. How volt? This is negative. So yesterday we learned about the electric cell also. So like for example, this is positive and this is negative. So in electric cell we have positive terminal and negative terminal. Why it is? Because the positive terminal, like when the chemical reaction happens, in the negative terminal side there is free electrons are there. Now we know that electrons are negatively charged, and because there are accumulation of electrons in the negative terminal, it called as negative terminal. Did you understand? So, now there is potential difference formed. How? There are more electrons in negative, there are no electron in positive. So there is a difference in the charges. Like accumulation charges is there in negative side, and there is no charges in positive charge size. So the potential difference is formed. That is why when you will attach to one circuit, then what will happen? The electrons will move from negative terminal to the positive terminal with the help of circuit, closed circuit. And when electron will move, so as we learned, there's a flow of electrons, and if the flow of electron is there, so there's a electricity, means electric current. So electric current will move from positive terminal to negative terminal. So battery creates potential difference, which is called as V. And because of that potential difference, there's a flow of electron, and flow of electron is basically called as current.
Sir, potential difference is the difference between the negative and the positive terminal.
Yeah, a negative or positive terminal in the battery. Okay, but like in normal range, we can say one point and another point. So there's one point and this one. Difference between them is called as potential difference.
Sir, I need to. mm, no, sir. Mm.
Okay, guys, did you understand?
Yes, sir.
Yes or no? Any
Mhm.
problem?
No, sir.
Okay. So, okay, write it down. I just give me a second. You guys write it down. Just give me a second, beta. Okay, done. Shall I? Okay, just let me write it down. This thing. Okay. So if 220 volt is applied to a conductor, then 10 ampere current is passed. Calculate the resistance of the circuit. Now, everyone, please pay attention. So, Betya, what is given in this question? What are the things which is given in the question?
Voltage is given.
Yeah, V is given, which is 220 volt, and it's okay. Tell me,
Then I think
what is this? What is this A represent? See, you guys remember this. If I am writing A is the unit of current. Okay, whenever A is given, it is called as current. A stands for ampere. A stands for ampere. So it is a unit of current. With, like, for example, if I am saying 7 ampere, means 7 ampere. Ampere means unit of current. 7 current. Like this. Did you understand? Like meter is the unit of length. Meter is the unit of length. In the same way, current unit is ampere. Okay, so this is called as current. So I is given, which is 10 ampere. Now we have to find resistance, and we have the formula V is equals to IR. V is equals to IR. So V upon I is equals to R. Now V is 220 volt upon I is 10 is equals to R. This and this will cut. R is equals to 22 ohm, which is the resistance. This is the unit of resistance, which is called as ohm. Did you understand, Agatha? Any problem? Ask me, beta. Ask me any problem.
no doubt. It's clear.
Okay, but still you go and check the video. Okay, as like you can do 2x 3x as much as you can do, and then so that it will be more clear. May I
Should I
clear?
write?
Any problem? Ask. Yes, yeah, write it down. Like whatever I wrote in the board, you have to write it down, because this will help you to make notes, and in the time of revision it will be easy for you.
So we will ignore that one, the one in like 10. So you cut
Yeah,
off the 0.
22 by 1 is basically 22. If denominator has 1, then we don't have to write this 1 again and again. Did you understand?
Yeah.
Done, sir.
Okay, shall I raise this? Everyone?
Yes, sir.
Okay.
Yes.
I think we have written this yesterday itself. So
Yeah. This is today's for revision, no? Little revision.
Uh, 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 uh.
Okay, write it down. Write one question. Okay, I will write it down.
Distributor rate capital rate calculate.
Done, beta?
Wait.
Who got the answer? You have to send it to me. Okay, me and Miracle will do this question. Okay, Miracle. Unmute your mic, please. Yeah. So first of all, you have to tell me what is given in the question.
yeah, the resistance 7.
Yeah. Resistance R, which is 7 ohm. Very good. Then
Then the volt 220 volt.
220 volt is given. Very good. Now what we have to find
We have to find the flow of current.
means I.
Yeah.
So I stands for I don't know. Now what formula you will use?
Yeah, the V upon I equals to R.
Yes, V upon I is equals to R. Basically, by the Ohm's law, it is V is equals to IR, and V upon I will become R. Now V is 220 by 7 is equals to R. You have to divide it. You have to tell me the answer. Did you understand, Agatha?
R is equal to I. V by R is equal to I.
Sorry.
V by R is equal to I, and 220 by 7 is equal to I.
Yeah. Sorry, my bad.
And the answer is 10 into pi. How can you not V by I is equal to R?
Yeah. So V upon. Oh my God, what is this? This is all happened when you didn't eat your breakfast well. Okay. So V by R is equals to I.
Answer.
Okay, done.
Yes, sir.
Agatha, done. Did you understand? Ira, what happened, Ira? You're not able to do it. Why, Ira? What happened, Ira? Why?
I got it.
Oh, then it's okay.
So we don't have to write the decimal down, right?
No, we have to write the decimal points.
I'm getting a
We have to do it. Sorry?
I'm getting a continuous one.
Yeah, it is continuous one. Na? So just two places. Two places is maximum you have to get. Like after decimal, you need two places. What's the answer? Tell me, Agatha. What's the answer? Yeah, mute.
31.42.
31.42. Now, what is the unit of current? A, which is ampere. So I will write A. Did you understand, guys? Yes, sir.
No, see, 220 by 7, you can just select, 22 by 7 is pi, So 220 by 7 is 10 pi.
227 is
10 pi. 22 by 7 is pi.
uh,
So 220 by 7 is 10 into pi.
yeah, very good. But pi is they see pi is 22 by 7, but 22 by 7 is not pi.
Can you solve this
What?
the dividing part?
Okay, so I will write 7 outside, 220 inside, then 7 threes are 21, then 3, sorry, 1 will remain as a remainder,
Okay.
then 10 will come. No, I have to do it now. No, I will do it. No, I will do it. Okay, so 7 1 7, then 3 will remain behind, point will come. So like this, you have to do it. I'm not doing it. Okay, did you understand? Yes or no?
Yeah.
Betty, turn on the camera, please. Okay, so I am erasing this. Okay, now everyone please pay attention. Okay, so I will ask you some questions. See, listen everyone. If I will increase, like for example, this is a pipe, and in the pipe there is a flow of water. Okay, in the pipe there is a flow of water. Okay, like this. So tell me, like you can check that it has more area. More area means more cross section area. What does this mean? This means that it has more width. This one. It is called as more cross section area. And it has less
Resistance.
cross section area.
More resistance.
Now you tell me, like, I will ask this question from Jashron. Jashron, which, like, option A or option B? In which of them the water can pass easily? Option A or option B?
Option B. Option A, you need a lot more force to do it.
Yeah, so it means that in option A, the um, the like the water will not pass easily. Okay, the water will struggle to pass through the pipeline. So from this, what we got that if I will increase the cross section area, the resistance will become more or less. Yes, Ira, you're saying
More?
something. Okay, so if I will, so I told you what is resistance. Resistance is the property of the substance to resist the flow of current.
I mean
Now,
less.
yeah, less. Less is the correct answer. Why, Ira? You also said more. Because, Ira, if water can easily pass, it is resemblance to current also. If current can easily pass, it means the resistance is less. So from that, what we get, resistance is indirectly proportional to the area of cross section. It means that if you will take the thick wire, mota, with thick wire, then current can easily pass through it and there won't be any problem. Okay, and the resistance will be less. So from this we will take one example. Okay, You know, in our meter, if you will go and check your meter, in that meter there is a thick wire is coming from the pole, from the electric pole. Why it is thin? Why it is not thin like this? Because as we learned, thin wire will have less resistance or more wire? More resistance. Miraculin? Thin wire will have less resistance or more resistance?
That's a resistance. So
No, thin wire, the electric current won't pass easily. It will have more resistance. Okay, just now we learned, na? If thick wire is there, then electricity can pass easily. It means it has less resistance. But if thin wire is there, it cannot pass easily. Then it will have more resistance. So thin wire have more resistance. So now from this we will get that if that the wire which is coming in the wire which is coming in our meter, if it will be thin wire and we will use geyser, AC and this thing, they draws lot of current. Okay, they will draw a lot of current. Now thin wire has more resistance. They won't allow the flow of current. And the geyser, AC and all these things need lot of current. So because of that, there is a fight between resistance and current. Current says, I want to go, I want to go, I want to go. Resistance will say, I will not let you go, I will not let you go, I will not let you go. And because of that, there is great amount of heat will be there. The wire will burn, house will burn, and there is a bonfire.
And if there
Did
is
you
a
understand?
bonfire, everybody living in that house will have a lunch with Jesus.
Yes, correct. Did you understand? Yes or no? So, like the wire which is coming from meter, you have to use thick wire. If you will use thick wire, less resistance is there. If your house needs to draw a lot of current, less resistance will allow the flow of current easily and there won't be any burning sensation. Did you understand? Yes or no what I'm trying to say? Huh? So thick wire has less resistance and thin wire has more resistance. So more resistance means less flow of current. Okay, and thick wire means less resistance and more flow of current. Okay, okay. Now, we will take one more example. This is the first one. Now we'll take the second one. Okay, now you guys tell me. Okay, now we have two things. It is big wire,
Long.
long wire. Sorry, my bad. My English is very bad. Long wire, and this is short wire. The cross section area is same, means the width between them is same. But one is long wire and one is short wire. So now you guys tell me which one is easy for a water to pass through a conductor, with the long wire or with a short wire? Yes, somebody saying
yeah,
something. Yes, Miracle.
I think it's short wire.
Short wire. Yes, correct. If long wire is there, so water needs to travel a lot in that wire, in that
Yeah.
pipe. Okay, so it is the same situation with the electricity also. For example, if the like for example, we can see Justron's fan. Okay, Justron fan, we can see that, and in that there is less wire is used. Okay, in that there is less wire is used. Now, if Jashron will take the wire which is to the fan, take 1 kilometer, 1 kilometer, like she will wrap it and she will make a round so that it will looks fancy and all. And if she will, it will be 1 kilometer round wire will be there, 1 kilometer. Then what will happen? that electric current needs to travel first to the switchboard and to the electrical wire, which is 1 kilometer. So it means that the resistance will increase. More length wire will have more resistance, hence the flow of current will be less. Okay, so from that we get that resistance is directly proportional to the length. If you will increase the length, then resistance will also increase. Did you understand?
Sir,
Yeah.
what is that 1 by A?
No.
1 by A is area of cross section. This is A is represented as area of cross section. It means that if you will increase the area between them, if you will take a thick wire, increase the area between them, the resistance will decrease. That's why thick wire has less resistance, more flow of current. But in this case, if you will increase the length, then resistance will also increase. Hence, less flow of current. Did you understand?
Yeah.
No. Okay. So from this, we got two things: more area, less resistance; more length, more resistance. Write it down.
Okay. Oh.
Area of cross section, length of cross section. Wait, I need to draw. Wait, okay, okay. Yeah.
Done, sir.
Done. Good. And which layer is this?
Wait. So thin wire is more resistance, thick wire is less resistance. Then long wire is more resistance, short wire is less resistance.
Hmm. So I will ask this question from Jashran. Jashran, if I will increase the cross section area by double, so what will it impact on resistance? If I will double the cross section area, then what it will impact on resistance?
Resistance will decrease by double.
Decrease by double means become half. For example, if it is was before 10 ohm, then become half to 5 ohm because I double the area. Did you understand? Huh? Ida, if I will increase the length by double, then what it will impact on resistance?
There will be more resistance
More resistance, how much?
by double.
By double. Yeah, it will be increased by double. Okay, Agatha, if I will increase the area by double and increase the area by double and increase the length by double, then what will happen?
There'll be less resistance.
Less resistance. Okay. Listen carefully. Again, I will say, if I will increase the area by double and increase the length also by double.
Will it be around the same resistance or?
Okay. Okay. Ira, what do you say in that?
I'm not sure.
I
No,
know.
what?
I know.
Yeah, Patrick, you know it, but just we'll ask first, and I will ask you. Yes, Ira. Whatever you know, just
I don't know. I'm not sure. I think it'll be the same.
okay. Betya, what do you want to say? What? You're eating?
No. I don't know. Maybe
If I will
it'll
if I will increase the area by double and increase the length also by double,
be more.
it will be more. Okay, more, more and chore. Yes, Tishran. What do you want to say? If I will increase the area and the length by double, then what will be impact on the system? No idea.
Give me chance, sir.
Yeah, I'll
It
give.
might
I'll give.
remain the same,
Sorry,
or
say it again.
it might remain the same, or it might increase or decrease. I think it's probably going to remain the
Okay, Edric, what about you?
Okay. So it will remain the same because both of them are double no, both area and length are double no. So it will remain the same, sir.
Okay, Miracle, what you want to say?
Yeah, I also say the same. Like it will be same.
Yeah, it will be same. Okay, how? So we know that if I will increase it by double and the area will also increase double, so 2 and 2 will cut, making the same. Did you understand? So if you will increase the length by double and increase the area by double, there won't be any change in the resistance. Did you understand? It will be remain same. Yes or no?
Yeah.
Okay. Okay. So now, okay, I will erase this.
Sir, but if like area is only doubled and the length is tripled, then there will be some resistance change, right?
Yeah. And because length is tripled, it means that there will be more resistance.
Resistance is equal to then 3 by 2 of 1.5
One
times normal resistance. 1.
become 1.5. Okay. Okay. So now we will understand one thing. Okay, everyone, please pay attention, and I will give you time to write. Okay. For example, this is a circuit. In this circuit, what is this?
Battery.
What? Battery. If only this is there, then it is called a cell, and if two or more cells are there, it is called as battery. Okay. So this is positive, this is negative, this is positive, this is negative, this is positive, negative, positive, and negative. Okay. Now this is a sign called as resistance. Okay, resistance. This is a sign of resistor. Sorry, this is a sign of resistor. Resistor. Okay, what are the resistors? Resistors are the devices. They are the devices that brings resistance. That brings resistance. Okay, so I will ask this question from Agatha. Agatha,
Brings the resistance or resists the flow of current.
yeah, both are the same. Okay, so I will ask this question from Agatha. Resistors are the device that are used to bring the resistance. So in the circuit, did we need resistance? And if yes, then why and where we used?
We may need a bit of that is hedge, right? KEJ.
KEY. Sorry, key.
Key.
No. Why I'm asking that we are using resistor in this circuit. So is like resistors will resist the flow of current. So is resistor in a circuit is really needed? If it is needed, then why and where we use resistors?
Mm, like you said, if there's too much okay. Resistance can stop a lot of current from coming together.
Mm.
From coming
Then
together and from causing a fire. Not quite sure.
causing.
From causing a fire.
Yeah, no, that is resistance of the material. But we are using a device, resistors, which looks like this. Like it always look like this. We are using this resistors like that. Okay, these are called as resistors. We used in this circuit. Okay, we want it means that when we are using it, we want the flow of current to resist. So is it necessary, or are we using this? If we are using this, so where we are using this?
In places maybe when there's a lot of current.
Is not needed.
Yeah, a
And
lot of current is not needed.
not needed. So can you tell me one place? Any one of the place in your house, in your nearby
Mainline,
object?
I'm not quite sure, but I remember like how electricians they wear gloves while working with wires. That glove is a resistor, right?
No, glove is the material, look, which does not allow the resistance. But resistors are the devices. Like this is devices, okay, which are used in the circuit. That glove is for their protection. We know that glove won't allow the electricity to pass through it because it has high resistance, high resistivity. But this is the devices are used in circuit so that if the device I'll give the answer. So for example, we'll take one example of using small thing like charging a phone.
Yeah.
Now we know that the electricity is used in geyser is very high because geyser withdraw lot of electric current, and that same electric current because mobile is has less resistance. If same electric current will go to the mobile, then mobile will burn, mobile will get destroyed in seconds. So we have to resist the electric current because too much electric current, if it will go, it will burn the mobile. So that's why we use. Give me a second. Yeah. So where was I? Where was I?
You and the part on saying that a device that can help resist the current, a lot of current when we are using a Or in the petrol station?
When we are using,
The phone in the petrol station or something?
not in petrol station, when we are charging, like when we are charging with the adapter, no, we are using that charger. The charger has a circuit in which resistors are used. Why? Because charger needs, like the our phone needs less electric current. If the same amount of electric current which geyser used, if same amount of electric current it will come to our phone, then our phone will dead. It will burn. So yes, we need resistors also, okay, so that we can stop the flow of electric current. Did you understand? Yes or no? So in the same way, registers, like if we want to show that register is used, we will draw like that. Okay. So now there is one question. This is 20 ohm resistor is there. Okay. And because electricity pass from positive terminal, so this arrow shows the direction of electric current. And if in 20 ohm resistance is there in the circuit and 5 ampere current is flowing. So the question is calculate the potential difference. Calculate the potential difference, which is V.
चलो हेल्प करो मैं
Ravi. Yeah. Done? Did you understand? What you got the answer? So the question is, if 20 ohm resistance is there in the circuit and because of 20 ohm 5 ampere current is flow, like 5 ampere current is flowing. So calculate the potential difference V. How we will solve this? Ira will help me.
Okay.
Yes, sir.
Wait,
So
so
what is given in this question? Yeah,
you have to find the potential difference. What's given is
V.
what's given
Yeah,
is the ampere, which is I.
I is given, which is 5 ampere,
Yeah.
and
Resistance is given 20 ohm.
20 ohm. And what we have to find?
We have to find V.
V. So what formula you will use?
V equal to IR, but we'll change it to
Hmm.
like I upon R equal to V.
Huh? I upon R is equals to V. How? We have the
Wait.
formula V is equals to IR, no?
Oh yeah, sorry. And then we change it 5 and 20.
So it means that 100 volt is the battery current. Did you understand? Write it down quickly. Miracle, Betya, everyone understood? Adric?
Yes, sir.
Tomorrow is a science test.
Oh, towards the science test.
Oh, God.
Okay.
I only.
Okay. I was totally forgot. Thank you, Miracle.
Math.
Oh, God. Yeah. Sorry.
Thank you. So So we'll do one thing. Tomorrow. Oh my God. Okay. So what chapter, by the way?
Oh, I will not tell both.
Yeah. I will try to remember that. What chapter?
Isn't it periodic classification?
Yes. Yes. Correct.
But you
Correct.
already did the test
Correct.
of that chapter, sir.
Huh?
You already did the test of that chapter, sir.
When?
On 17th.
Only half you did, no? So rest half you have to do. It means that full. Half and half will become full. So full chapter is coming tomorrow.
Tomorrow is a test? And math test? Math test?
Math test will take after the week. So we'll do one thing. Tomorrow is no test. Okay, but
Okay.
next week
Thank you,
next week
sir.
I will
Thank
take.
you, sir.
Next
Yeah,
week, Friday is the test?
next Friday. Next Friday there will be test of science.
Math? Math?
No,
You
science.
haven't yet said the chapters that are coming in half yearly.
Okay, I will send after the class. Pakka. Today.
Ma'am, sir.
Yeah.
So when is math test? When is the next math test?
Next test will be the next to next week then.
Oh, but I don't want tests like every week. I want every 2 weeks. So can you keep the math test and science both on 21st?
Yeah, we can do this thing then.
Okay.
Perfect.
Both math
So
and 21st.
we will do one thing that both maths and science tests will be on the next week,
21st, Friday.
21st. Okay, Ira? Ira, put the message in the group about the test.
So the math
Yeah.
test will be coordinate geometry, right?
Yes, coordinate geometry. So both subjects. Yeah.
I didn't really fully complete periodic classification. I need to cover a few more topics in periodic
So
classification.
do one thing now that on Thursday, like next week, Thursday, we can arrange a doubt class. So if you have any doubt, you guys can come with doubts. Okay. Any topic that you are not able to understand, do it. And then on Thursday, we'll discuss it. And Friday, there's a test.
And sir,
Yeah.
Yes.
so then, and sir, and I also didn't do the test of chapter 23, the trigonometric ratios of some special angles.
Yeah, we will do it after some time. But this Friday, I mean, the next Friday, will be the chapter of coordinate geometry as well as periodic classification. Thank you, Miracle, for reminding me.
And sir,
Yeah.
and you also forgot to correct the tests of.
Yeah. So this Friday, because this Friday, I believe there will be holiday, but I'll discuss with my co-staff and then
Games.
I will let you know.
We want games.
Yeah. So if I will get time, we will arrange the games part. If it is not, then there will be holiday because of Children's Day. Yay!
Children's Day.
Okay, so now games.
Okay.
Okay, so games. So games
Yeah.
and
If I will get time, then I will arrange the games time for you guys. If it is not, then there will be holiday. I will ask to my co-staff. Okay, we can do one thing that we can take all the students in one class, like whatever, like small kids to the big kids in one class, and we can then arrange one games. So we'll
same
discuss it and then we will let you know. Okay. Okay, guys, you have 2 minutes break. Then come back in class.
sir. Bye.
Okay, guys, come back. Come back.
Okay.
Okay. So we learned about resistors, and we know that how to draw resistance in a circuit. Now, everyone, please pay attention. Agatha, everyone, please come back. Turn on the camera, guys. Quickly. Miracle in Agatha. Turn on the camera.
Ookie.
Okay. So now we learn about that. Now, resistors can be arranged. Resistor can be arranged in two forms. Resistors can be arranged in two forms. Okay, first is in series form. How the series form look like this. Like one after one. This is first resistance, this is second resistance, and this is third resistance. Okay. This is first resistance, second resistance, and third resistance. So please don't write. I will give you time to write, guys. Please pay attention. This is important. Okay. So when resistors are arranged one after one, Edric, don't write, please. When resistors are arranged one after one, then they are called as resistance in series. Did you understand, guys?
Yes.
Yes or no? Resistance in series means when resistors are arranged one after one. Did you understand? Yes or no? Any problem in that? Now, second one is parallel. Parallel means when resistors are arranged one above one, means like this.
RAG Enterprises. Malt is very cheaper than Vishwa. Gold, check. I've just sent you.
Okay. Okay, everyone, please pay attention. If resistors are arranged one above one, then these resistors are called as parallel. These are parallel one and these are series one. Did you understand, guys? Any problem? Yes or no?
The ones who are arranged in an orderly line, they are called cine. What's that?
Yeah, my God. Agatha, you are insulting my gold medal handwriting. Okay, so this is called as series. 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 Okay, not Cine, not Siri, not Alexa, nothing. It's series. Okay, so this is series which is one after one. Okay, and if one above one, it is called as parallel. No parallel, no parallel. Okay, so parallel is one above one. Did you understand? Yes or no? Okay. Now, in this case, guys, everyone please pay attention. For example, if current is passing, so if I current is passed, then whatever the current whatever the current of the circuit, it will go in R1. The same current. Okay, so whatever the current which arises from battery, the same current will go in R1, the same current will go in R2, and the same current will go in R3. Means the I will remain same. Did you understand?
Yes, sir.
Agatha, Edric, I will repeat it again. The current which arises from battery, the same current will go in R1, the same current will go in R2, and the same current will go in R3. Did you understand? Yes or no? Hmm? Okay.
Yeah.
Now, if I will talk about this, that if I will talk about this is V voltage created by battery. If I will talk about this, if current I will go from this, so there is a problem in that. What the problem in this? Like if current I is going this, now because there's a division in the line, then current will also divide into I1, I2, and I3. they won't be same current will go. Because I told you resistance, if resistance is more, current is less. For example, if R1 is more, then less current will go. Not full current will go. Na? Current always wants shortest path and less resistance path. So according to the resistance, here there is same single path is there. So if single path is there, current has to go with that resistance only. There is no there less resistance or more resistance. He doesn't have any option. But in this case, based on the resistance, it will drop because it has different paths. So I1 will go according to the R1, I2 will go according to the R3, and I3 will go according to the R3. So now after when they will separate, they will become one again, like this. Did you understand what I'm trying to say, Agatha, Miraculin? I will explain it again if you didn't understand. Ask me. Ask me, guys. Any problem in that?
Okay, so sir, so what about
Yeah.
the voltage in both? What about the
I will
voltage?
I will tell. Just give me a second. Till here, any problem? Yes, Agatha.
Okay, so the current which is going on R. Okay, so the current has, so in parallel, the current has a choice to go in R1, R2, and R3. The current,
Because different pathway.
yeah, there are 3 different pathways, but they'll connect in the end.
Yeah, connect in the end and become I again. So the I current which is arises from battery, the same I current will go into the battery. That makes the circuit.
Okay.
Okay. Now we know that, everyone please pay attention. We know the Ohm's law formula, which is V is equals to IR. Okay. So in series, what is constant? I is constant because I is not changing. Okay. So we know that in series, V is equals to IR. I is constant. I will write constant. Now, if R will change, because I is same, I will remain same. If R will change, then voltage will change. So it means that across the each registers, it means that across the each register, the voltage will be different. And we know, I told you, voltage is measured by voltmeter and it applied parallel to the circuit. Did you understand, guys? Yes or no?
Yes, sir.
So in series, voltage is different. That is why the I is same and R1 and R2 and R3 changes. So we know that. And in this, the voltage across the resistor will remain same. Okay, the voltage across the resistor. Okay, did you understand, guys? Yes or no?
Sir.
Did you understand?
Okay, so in second case, the voltage across the resistor will remain same. So in the first one,
Yeah.
the voltage will be different, but in the second one, voltage will be same.
Voltage will be same across all R1, R2, and R3 because they already arranged in parallel. So if I can take single voltage across them. Okay. So from that we got that. Please pay attention. Don't write. Betya, you will not get anything otherwise if you will write. If you're writing. Okay. So in series, I means current will remain constant. Okay. And in parallel, voltage means V remain constant. Did you understand, guys? Any problem in that? Jasran, any problem? Ask me. Okay. So we get here voltage different as V1 plus V2 plus V3, and the total voltage like V1 plus V2 plus V3 will equal to the voltage coming from battery, which is V. Did you understand? Yes or no? the V1, V2, V3. Like for example, if I will take this as 4, this as 5, and this is 7, so the total voltage will be equals to 19, which is 4 plus 5 plus 7. Sorry,
16.
19 is 16. 16. Okay. So V1 plus V2 plus V3 will be equals to V. Now V1 is basically IR1 because we know that V is equals to IR. We know that V is equals to IR. So V1 is equals to IR1. V2 will become IR2 because I remain constant and V3 is equals to IR3, which is equals to voltage is equals to IRS. Did you understand what I did?
S means series.
Ira.
S means series.
RS means resistance in series. If you will apply the resistance in series, RS means. Okay, resistance in series. So I repeat it again. We have the formula V is equals to IR. Okay, so V1 is there because I is constant. So I wrote I as I and IR R1. The same V2 R2, V3 RT, and this V is equals to IRS. Did you understand? Yes or no? From that, I will take out I as a common. It will become R1 plus R2 plus R3 is equals to IRS. Now I and I will cut. So R1 plus R2 plus R3 is equals to resistance in series. What does this mean? This means that if the resistance are arranged in series and if you want to find total resistance, you have to simply add it. Okay, like 7 ohm, 8 ohm, and 5 ohm is given. So what will be the answer? 7 ohm plus 5 ohm plus 8 ohm plus 5 ohm will become 20 ohm. So means 20 ohm the total resistance. Did you understand, guys?
Yes, sir.
The total resistance will be V1. No, I mean R1 plus R2 plus R2.
Yeah, if they are arranged in series. Only if they are arranged in series. And if they are arranged in parallel, we will find it out in the next class. Till here, any problem?
No.
Till here, any problem? Guys, Jashran, Betya, Ira,
Yeah.
quickly write it down. Quickly write it down. Make this thing in a landscape mode, okay? Not portrait mode. You have to make it in landscape mode. Why I'm saying? Because tomorrow that we are going to do, we have to do the parallel part also. So we will do side by side. Jashran, did you understand better? Yes or no?
This might take 10 minutes to draw.
Okay.
जितने बचेंगे उतने देंगे.
Okay, done. Okay, guys. So we'll do one thing because Rebecca ma'am class will start. So I will send this same chart into the group. You guys do it from the group. Okay. And then we'll meet tomorrow and we do the parallel part tomorrow. So I hope you enjoyed the class. Till then, bye. Have a nice day. Signing off. Tata. Shabakher. No, Tata. Bye bye. Shabakher. Sayonara.